Engineering-based development appraisal to general public, professional awareness, backbone of any nation, hidden works, sacrifices for development, small returns, buildings by professional engineers. Suraj Singh, New Delhi. An engineering block for assistance and creating awareness for the general public. Good morning. This is Engineer Suraj Singh, civil engineer, experience on buildings and oil projects. I intend to give my thoughts, my opinions for the use of general public in Bharat who are well unaware about what the building should be and how the engineering should move. They are not clear about. This is serial number 1. I have given on the blocks, but I am just narrating now. The objective. The world of engineering, engineering sciences, their applications, impact on the economy, health, safety and environment, quality, society, all relevant as others. Number 1. Engineering science applies to the whole world developments. Engineering is the basis of any society. Without engineering, the human had to remain ancient. Number 2. Engineering is an art-based science with widest network. In fact, engineering is a mind religion. Without engineering, Ramayana could not be completed. Number 3. Without engineering, nothing is possible. Yet the professionals are most unbeneficial and society is unaware about their sacrifices. Number 4. No politics can sustain the national advancement without the role of engineering. Engineers can change the national power and status of the world. Number 5. All other professions shall be worthless without the contribution of engineering in the global scenario. Engineering travels its journey from a dream to a made-up project, a dream come true. These 5 are the objectives which we have elected for explaining about the engineering sciences, their applications, and whatever other sectors involved with that. Let us now give a more view on this. The public of the world, the public of the whole world, living on the earth, has been developing various nations as well as the globe. The contributions from all fields of human life are responsible to make it. But a considerable contribution comes from the field of engineering of all disciplines. Without the contribution of engineering, life shall cease. The history is full of various regions. The history is full of various regions of engineering all over the globe. Though there was no engineering education in those days, yet the minds were full of engineering knowledge, inculcated either by the God gifts or by the clan work inherited from ancestors. Engineering contributes from the manufacturing of a needle to the space vessels. All systems are running based on any branch of engineering. The engineering involves a part of art, applied mathematics, applied sciences, and the health, the safety, and the environment, with the assistance of all codes and the national and international laws. Engineering is a very complex term in the stage as contribution from various engineering disciplines are required to accomplish any small task or manufactured price. Further explanation is, engineering term comes from the basic word ingenious. Engineer means a mind, that is genius. Though the education of engineering varies from 5 to 7 years, yet the education is merely not adequate to work as an engineer. The formal or informal education can help a person to train the mind to work in a particular direction based on the learning modes. The education achieved from any university does not equip any person to do anything in engineering immediately. It takes a lot of time for any mind to do practical job after passing engineering education, engineering degree. The university just equips the person based on the books written by the professors, and the student learns the volumes of the collected syllabus. The imagination within a student is developed, but the application remains distant yet. Sri Krishna said in Gita that knowledge is incomplete by just learning the theory for making up, that the learning by experiencing its practical aspect is a must. Repeat, learning by experiencing its practical aspect is a must. The direction of Krishna still holds good in the modern age, so-called advanced world. Engineering is a very wide field. Currently, there are more than 15 major branches of engineering all over the world. There was a time, some 30 to 50 years back, when only a few engineering branches existed, namely civil, electrical, mechanical, and in addition, of course, architecture. Of late, engineering by the designation IT, that's information technology, has been added to the existing lot. Even now, the basic fields of applied sciences that being engineering are merely civil, electrical, and mechanical, while the other branches are the specializations from within the various chapters of engineering. All branches of engineering have further vast volumes of various specialist subjects, and they are limitless. Engineering is very much technical, and it makes the full use of the mind during the small age of 20 to 25 years of anybody. The learning period, by getting a certificate of any engineering degree, makes the person fit to understand the subjects related to the engineering successfully. A further period is necessary to start applying the engineering knowledge independently. At least a period of 5 to 7 years minimum is considered adequate for finishing like internship. A degree of confidence is attained by the engineer after say 10 years of professional experience. This explanation is just to let the people know about the engineering education backgrounds. The engineer has to dispose of various duties in the fields. It is a fact that in general all the national and the international projects are located in the countrysides or at the shore. By virtue of the nature of projects location near the seas or in far-off cities or within the defense forces, the majority of engineers from all walks have to remain posted in such remote areas for most periods of their careers. This situation of engineers' postings and location varying from one place to another makes the engineer distant from the views of the general public. The public knows about the works done by a doctor. Also, the works of other professions are seen by the public live every day during day-to-day business, day-to-day livings. The news on the TV and the print media carries every day about all professions by virtues of their indirect involvement. The result is that the public knows very nicely the contribution by all such professionals. The works done by the engineers away from the eyes of the population do not let the people know about the contribution of the engineering to the society. Consider any development work being used by you and just think on what category of engineers and the workers have worked on the construction of the project from the inception to the handover and commissioning stage. For example, take the case of metro railway construction. From the initial surveys to the commissioning, all category of engineers must have contributed from all the parties involved. Otherwise, the project cannot be executed successfully. Parties that I have used the word here resembles to government, resembles to contractor, and resembles to consultants and various others. All projects import various classes of engineers and the para-engineering staff finally supported by technicians and artisans of all designations. Metro requires the manufacturing of tracks, manufacturing of train, the surveys of the geological sections, the water bailing out, the tunneling and the overhead operations, the electrical and the electronic networks, access controls, mechanical equipment, high level of safety and many others. Let us take, for example, a building construction. There are various classes of buildings, but for now, just for explanation, let us consider a normal reinforced concrete residential building. Generally, all you are aware about such building all over the world. The term RCC is used for this type of building. R stands for reinforcement, C stands for cement, and C stands for concrete as well. In the previous decades, stone was generally used for the construction of buildings, but due to the lacking of tensile properties in the stones, an artificial stone as RCC is used. Bricks have also been lately replaced by RCC. Concrete is defined too easily, though it looks difficult to answer by anyone in case a question is raised. Concrete is a composite mixture of various types of aggregates, water and the cement. Cement stands for name of the material, yet it works as a verb in this case. The cement means a material used to bind the fine and the coarse aggregate. Rocks, small pieces are called coarse aggregate, while the sand used is called the fine aggregate. Water is used to allow for the chemical reaction of the cement to produce a gel that sets in a couple of minutes to hours, filling in the voids of the combined aggregate. Sand and the stone aggregate so that the volume of all the ingredients becomes like stone and is called concrete. The cement itself comprises a majority of lime and silica. Many additives are used to inculcate many properties into the cement product. In fact, the cement is the cement is an advanced stage of modified lime. Cement works in concrete as a binding or cementing agent for all the aggregates with the help of water. This is the reason the name of the material has been given as cement. The origin of cement is located at the Portland that has allowed the name of Portland cement. We are talking about the very ordinary type of cement designated as OPC, ordinary Portland cement. Ordinary Portland cement, I repeat. There are many types of cements for different designated purposes. Generally, in construction of buildings of RCC types, bricks are also used, though rarely recommended. Generally, the bricks are made of clay by blending, then molding or casting, and then baking at high temperatures in brick kilns. Clay is a refractory material that can withstand high temperatures. There is a bad property in clay that it is not good for the water affinity. Clay as a soil is a bad material as the nature of clay cannot be correctly predicted. When the clay comes in contact with water, it absorbs heavy quantities of water and swells to many times of original volumes and after drying is squeezed again. This type of the property of clay is dangerous. In some places, concrete blocks are used for the construction of walls. The concrete blocks are better in conduct than the bricks. The RCC is a suitable material for the construction of buildings as it can be designed and constructed in any shape. The steel bars are used to be embedded in the concrete mass so that the impossible loads of tension are taken by the steel bars. The concrete is not able to take the loads of tension. The concrete is a good material to take the compressive loads. The concrete is a flexible material and in combination with the reinforcing bars of steel, it gains all the properties of making a good building frame called structural framing. A building is composed of many frames in both directions on plan and also vertically. The direction on plan means x-axis and y-axis geometrically and z-axis vertically. You may say that the building is a three-dimensional frame structure. Hundreds of forces of compression, tension, bending, shear, and many others are composed on the structure by the loads of few people using the building as live load. These forces impose themselves on the structures. the weight of the RCC materials, and all other permanent materials called the dead loads. The loads of the winds in the horizontal direction and the loads of the earthquake forces in the horizontal direction. The wind load applies from the top of the building to the bottom, while the earthquake loads apply from the bottom to the top. The engineer has to design the building based on the possible imposed loads as described in the various codes of engineering throughout the world. Various formulas are applied while calculating the values of various forces. The first attempt is that the engineer called the structural engineer, basically a civil engineer, or a civil engineer experience on buildings has to conceive the framing architectures either by self or based on the architect's design as the case may be. The engineer has to satisfy the architectural requirement as well as the requirement of the codes and the personal input of gained knowledge by self-experience. It is the capability of the structural engineer to use the materials, properties, and the stresses to the optimum level so that the minimum quantity of material is used in building construction, while the building serves safe for its serviceability lifespan. Initially, the designs are to be taken up in a judicious manner by the structural engineers, keeping in view all points of meeting the design criteria and the financial economy to minimize the budget. Engineer risks any lives while designing any building. In fact, the job of a structural engineer in the civil engineering field is very significant. The engineer has to think for any decision 10 times or more. The decisions are not that easy as any layman standing on site and start laying the settings without any drawings. Any building takes a lot of time to design these days. Even if the aid of the computer is available, a deep thought is required for every decision as a coordination with architecture is also significant. Simultaneously, no foundation can be designed without having a good knowledge of soil engineering of the physically soil available at the strata of the proposed building. Simply going deeper into the soil does not serve the purpose of a good and strong footing. The old saying that deeper the foundation, stronger is the building is senseless approach. Then we can say engineering-based development appraisal, the general public continues in other ways. For example, we will see that if we go ahead with this, soil engineering is a very vast subject. This is now serial number 2. Soil engineering is a very vast subject, but for the information of the general public, I have tried to brief about it. The nature of the soil is not fully known. How shall the soil conduct its performance is not absolutely understood. No soil engineer around the world can guarantee the resistance of the soil to any definition. Just like when any earthquake shall occur cannot be predicted, the same applies to the complex soil structure. Yet an advance has been made in the field of engineering for ordinary building constructions. Generally, the following types of soils are met during surveys. The soil could be sandy or sand. If the soil is sand, it may be dry or wet or moist. The soil could be dry, should be clay mixed. The soil could be clay mixed or silt mixed. In Bharat, in India, at so many locations, black cotton soil is also available, that is clay. Sand comes under the classifications of granular material, while clay and silt comes under turquoise materials. The availability of sand is better than clay or silt. Even moderate density sand performs better than clay. Soil investigation is very significant activity. It may cost some amount, but if the designer is experienced, the investigation can be done on site by visual experiment of sedimentation. For moderate small buildings, it is not very essential to get into picture the soil investigation laboratory or soil investigating laboratory, since the laboratories are not available everywhere. You as a common man, or you who are not clear about engineering, have every right to know a brief about the engineering. And the purpose of my giving information to people is that people spend a lot of money on engineering works, generally, particularly for buildings that are constructed by directly by ordinary people like you. You may be rich, or you may be middle class, or you may be very industrial class. Everybody has to spend some money for a home, which is the life dream for everybody, from poor to rich. It is therefore very essential that you people must be made aware about the involvements in any building. Simply constructing a building like a layman, assigning responsibility to a mason or to a carpenter or to a ill-qualified builder, and then he spoils your money by constructing your building the way they wish or the builder wishes. The best thing is an engineer should tell you about your building. Particularly nowadays, you people do concrete buildings. The stone time has gone, and the structural steel is not used in residential buildings for various reasons. Industrial structures are different. The purpose is to tell about the RCC buildings that you and everybody is doing. Even you are getting flats from the government departments or the authorities. They construct the buildings in RCC and brickwork or blockwork. You must know about what the building is constructed of. And when you construct of your own, it is better if you know something about the building so that contractor or the builder cannot be fool you. RCC building is very important for your future because RCC has a capacity. RCC means, as I explained to you, reinforced cement concrete. Reinforcement is the basic word that was used sometimes for the engineering of military exercises. When there was army deployed on the borders, they used to fight. Many people, many army jawans used to die. There was shortage of army forces, and these forces then used to send the message to the high commandant that send the reinforcement. Means some people were depleted, they were out of their strength. To replenish those strengths, reinforcement of army was required. Similarly here, the case of concrete. In the concrete, compression capacity is very good. It takes the compression, but there is no building, there is no beam, no column, no slab which just survives on compression. Every member is stressed as in compression as well as in tension. These are basic stresses. Then there are other stresses like bending moment, like shear force, like deflections, like crack controls. So many other things are the crack formations, thermal expansions, blast loadings, which are far higher in engineering. We will not discuss here. Here we are discussing compression, tension, and movements. Now, say for example a beam, which is a horizontal member in any building frame, a column, which is a vertical member in any building frame, a slab, which you call generally lenter, that's a horizontal member in a frame. So a lenter is a slab, suspended slab we call it. Columns are vertical members, beams are horizontal members, foundations are below the ground, that are different types of members. That can be beams, that can be footings, that can be raft, and that can be pile, depending upon the requirement of a building. It's therefore very essential for general public like you to know the basics of a building. The basics of a building are foundation, frames. Frames means 1, 2, 3, 4, 5 at various spaces, and then cross frames like this, 1 to A, B, C, D, or E, whatever it is. These frames are composed of, we generally call them portal frame while learning engineering. But these are multi-story frames when you are considering 2-story, 3-story, 4-story, or 5-story, or 6-story. They are multi-story frames. So basic elements are frames in any building. Foundations. We analyze frames and foundations in engineering. That analysis is a part of theory of structure and RCC design. There are two components. One is analysis and another is design. And before that, analysis is very important. Analysis imparts you what stresses are going to impose themselves on the buildings, on the frames. When you are, imagine a building is constructed, you are using that building. Your load is coming on, that is live load. You are using goods in your home. These goods, trunks for example, anything in home, chair, table, desk, these all are considered as live load. Concrete weight is considered as dead load. Similarly, weight of finishes are considered as dead load. Any item that is permanent, that is permanently included within a building is called dead load. Similarly, there is load like wind load. The effect of the wind on the building is wind load. The effect of the seismic earthquake on the building is called earthquake load. These loads are to be understood. This exercise is carried out by structural engineers. In architecture, this is not very detailed. They just know the basics of this. But this is very complicated exercise. Engineer has to understand. Engineer understands actually, not has to understand. Experienced engineers understand what loads are going to be applied. But as an owner, as a user, you must also know what loads have been taken. So all these loads are collected. Dead load is collected in calculations. Live load is collected. Wind load is collected. Seismic load is collected. Fire factor is collected, and thermal factor is collected, blast factor is collected. All these are given in the various codes of the world of various countries. These loads are considered, are taken for every frame of your building. Every frame takes some load, draws some loads. How it draws, that is a part of detailed engineering. So on the frame, from the slab, load comes. Slab gives loads, your loads to the beam. Beam transfers the loads to columns. Then columns transfers the load to the foundations below. And foundations transfer these loads to the soil below. And soil is very important material. Generally, people don't understand the soil is also a material. Soil has the capacity to transfer the load to further soil below. And this way, the building is analyzed. For every member, we have to analyze. For every class member, we have to analyze. This is the job of the structural engineer, but just for information, I'm telling you. This is very important to analyze correctly. Analysis is not very small. It was very big calculations. We used to do very big calculations and there was no computer. But now computer is there, various softwares are there. Based on those softwares, using those softwares, detailed analysis can be drawn. After doing this analysis, we form thick volumes of calculations which are completely mathematics based, formula based. Engineer has to understand these, engineer has to interpret these, apply various types of loadings on your buildings. After applying the loadings, engineer has to know the stresses, moments, bending moment, whatever shear force is there. He has to check those. They have to see that while direct loads are applied, means vertically applied without considering wind load and stress load, what are the results of the frame? What are the forces? Then they have to apply the loads in parts. Dead loads somewhere, dead loads in full, and then see the stresses, and dead loads plus certain half live loads you can say, and then see the results. Then we have to apply wind load and then see the results. Then we have to apply the seismic load and then we have to see the results. All these applications of loads at various stages in calculation shall give the critical results, most critical results. And those critical results shall suggest the engineer, shall direct the engineer what forces are to be considered. And that is what the analysis is. Based on those designs, the work is to be done and design is to be carried out. That is very, very important. Once detailed study is done, design shall be done, building shall remain safe. But soil investigation is a very important factor here, because soil investigation is a separate chapter, that is a geological engineering chapter. If your building is very big, it is better that you ask your engineer, your consultant, to investigate about the soil. You will ask certain laboratory to come and investigate the soil. The soil investigation report shall give the complete idea of the building. It will be 20-meter deep borehole, it will be 30-meter deep borehole. You will get the results of bearing capacity. You will get the various results of soil properties, how much electrical current it can resist, how much water quantity it can allow through, that's called permeability. How many volumes are there in the soil, how much quantity of water it can absorb in this. There are so many other properties and parameters of the soil. What angle it shall make when left on the ground. When you leave the soil in the ground, it shall make certain angle with the horizontal. That angle of repose we call it. What it will be. What will be the density of the soil. What percentage of impurities are in the soil. What percentage of salts are in the soil. What percentage of chlorides are in the soil. How compressible is the soil. What is the settlement of the soil. How can the best behavior of soil be known before the design of the building. All these properties are very important. These are called parameters. If we know all these, a factor can be applied by the engineer. Suppose an engineer comes to know from the soil, this bearing capacity is 100 ton, but the soil engineer recommended 5 or 4 a factor of safety. So bearing capacity shall be 20 tons or 25 tons. Be taken by the design engineer in his design. He shall check what is the settlement of the building. Settlement means when building sinks down. If it is same settlement, uniform settlement, danger is less. But if the settlement is uneven, suppose in one corner it sets to 20 millimeter, the other corner it sets 100 mm. This is very dangerous. Based on this design information, a building has to be analyzed on every member. Three-dimensional design will be, analysis will be done, two-dimensional analysis will be done, various softwares can be used, and this shall tell the engineer about all the members of the buildings. A building may have 100 members, 200 members, 400 members, 1000 members, depending upon the size of the building. Members means we call member. Slab panel is a member or slab is a member. We also call slab diaphragm. Then column is a member. There are many columns. Beam is a member. There's another beam in would be, which is also a member. Foundations column is a member. Foundation is a member. Foundation beams are members. Like this, there are thousands of members in the building. Engineer structural engineer is supposed to design, supposed to study, supposed to analyze each and every member of the building if you want a good building, a strong building, a live building. Of course, there will be some expenses, but you will get a durable building. Durable is very important. Construction of building is not sufficient if it is not durable. Durable means the building can sustain long-term imposition of loads. Today you are constructing this nice building, new building, but the same stresses go on reducing their capacities. Members go on reducing their capacities in long term, say after 20 years, 30 years, 40 years. And it's not necessary that whatever has been taken into design, architectural consideration or structural consideration, electrical consideration, you use the building that way. There can be different type of uses. You can sell the building, other guy uses the building a different way. All these factors are very important. How the concrete is behaving, how the plaster is behaving, how the steel is behaving is unknown. These are only virtual considerations. What is happening inside the concrete about to steel, how is rusting or not rusting, how much water is penetrating from the weather, or what moisture is entering into the cover of the building. That's very important. Really the building is dense or no, because we are taking theoretical consideration, but you have used 1000 times mix the concrete for the building. Every 2 bags of cement or 3 bags of cement or 1 bag of cement shall mixes are delivered to the buildings in batches. Thousands of batches are there. Every batch is having different properties. It varies because aggregates in one truck and aggregates in